Okay, so we talked about disease scores and how these scores can be done using normal distribution and information above that gives you information about disease or the standardized, we refer to it as standardized values, and that's using standard normal distribution. For these problems here, we're going to be looking at value information that comes from actual data, the real numbers, the real values, the real measurements. So we're actually referred to as being the real normal distribution when selecting one single subject, so we're not doing groups yet, we're just doing a single subject, and the single subject is going to be satisfying certain ranges of the measured X, not necessarily the measured Z-score, or standardized value. And we're going to be using the different types of TI graphing calculators in order to get it done. So I know we're going to be converting in the Z-score, I'm just going to go straight forward into measures. So I won't be doing any of these conversions, I'll be straight just using the parameters measures. So these scores are just a guideline, but I'm not going to use them. And they're guideline to actually getting the actual parameters of the X measures that focus on the normal distribution curve. So all we're saying here is when working with probability questions that involve a selection of one subject that satisfies the condition for the range of measurements X, so measures of X, we can use to give information about the population's mean standard deviation and standard deviation. In addition, the population must be approximately bowl-shaped or normal, however you want to say it, bowl-shaped or normal. We're going to say the same thing. Some books even say symmetric, or say normal. And some other books might say symmetric. Both, they all mean the same thing. Bowl-shaped, normal, symmetric, all mean the same thing. Anyways, we get that out of the way. So all we're saying here is, and generally, all we're saying to do is, if we want to jump, all we're doing is adding one standard deviation to the right to get to the first one standard deviation away. If I want to jump again, I'm just adding another standard deviation because I'm adding two, so they're from two standardized values away in front of me. And then if I do one more, I'm adding one more standard deviation. So therefore, I get three. So it's a addition or subtraction of standard deviations. If I want to go to the left one standard deviation, I'm subtracting one standard deviation away from the mean keyword. Most important thing is the mean, the mu. And then again, I subtract another standard deviation. Now I'm definitely officially two standard deviations away, or I go like this. So typically you can do this by hand, or you can calculate by constantly adding, subtracting. It's really a choice on how you want to do it, or you can do list operations and get this all in one go by putting this in this one, and then we get the expression that corresponds with it, and the two lists two. That's really how it works, and pretty much it just comes down to your perspective and how you want to set up this table, this diagram, this image to help us out. But anyways, let's go ahead and continue with the problem that is. So once again, I'm not going to be converting these scores. I'm not doing this portion. I'm only doing the parameters of the row X, and I'm going to be using calculators with the actual values instead of converting. That I'll save for another video, not for this one. So let me go ahead and race and get to this, get to the main idea. So let's look at the first example. What's it saying? So over here, we definitely notice over here, we're saying that a study showed that the height of men are normally distributed. So that's good to know. We know it's normally distributed. That's wonderful. So I definitely use the Gaussian curve, or aka the normal distribution curve. And then with the mean of 6 inches, so we know this is our mean. So this is your mu, 6 inches. This is your mu. And you have our standard deviation of 2.9 inches. And that is your standard deviation sigma. So sometimes when you read information, just make sure you don't confuse what's important information and what information can be needed in terms of answering questions and whatnot. So all we're saying here is, in addition to the standard deviation and mean, we're saying that a luxury plane has a doorway of 59.2 inches. So in retrospect, what this is really saying is this permanent audit is saying this is some X measure. That's all it is. It's just some X. We don't know what it is. We might be using it, or we might be using other measures. It all depends. But that could something we could be useful in terms of answering questions. But first thing first, let's just go ahead and get this parameter word. I want to see, okay, if I'm going to ask about 52.9 or 59.2, where's it located in here? Because we should already know how the first group is working in terms of the middle 68, the middle 95%, the middle 99.7%, and whatnot, which is a good thing to always keep in mind. And I get to put it in the bottom when they get these guys set up. But first and first, let's get this set up. So at this time, all I know at this time is that my mu is going to be, in this case, it's going to be your 68.6. So we're seeing there where your mu is located. And over here, all I'm going to do is I'm going to increase by 1 standard deviation. So I'm going to, you could add by 1 standard deviation over here, which is add by 2.9, and you can consistently get that same jump to occur by just simply increasing it by adding a 2.9 each time. I'm going to do one lump sum, and then I'm going to be erasing what's right here. But that's what we're really doing. And my name is the space right here. Over here, similar over here, if one goes 1 centimeter to the left, well, that means I should be decreasing it by subtracting by 2.9. And I repeat the same process. If I want to go 2 centimeters to the left, or 3 centimeters to the left, I'm going to continually decrease it by the same amount of centimeters. Same is going to happen every single time. So over here, minus 2.9, minus 2.9. And so, once again, I'm not going to do all this by hand. I'm going to do using this operations and get it all in one go. That's what I'm going to do. So once again, it doesn't matter which calculator you're using. If you're using the TI-84 or the CO or whatever calculator, we also know how, as an example, we know how to do this operations. And what I'm going to do for these two here, I'm expecting those of you guys in my class to already know how to do it using your calculator. But anyways, let's start with the TI-84, since most of you guys have this one. So always remember, it's always under a stat, and you'll be editing your list. And then all we're going to do here is, since I want to go 3 to the left, always 3 to the right, I'm looking at it being -3, -2, -1, 0, 1, 2, and 3. So I got all my standardized values extending to the 3 centimeters to the left, and extending to the 3 centimeters to the right. So now I got to do over here is put the expression needs to be here. I didn't write it over here like a smart one. I'll put it right here. What's supposed to be, once again, how do I get these guys in general? What's generally happening here? All we're saying here is the x measures that we're going to be finding that go into this box, and this address is going to be equal to the mu plus where our standardized value is times your standard deviation. So what we're looking over here is at 68.6 plus, and our standardized value is going to be going from our list, which is this one. That's your list of all your standardized values. And we're going to times that times it by 2.9. And that's what we're going to do. So I'm going to set it over here. I'm going to go to this, make sure it's highlighted up top, what's working. And for TI-84, you press enter. And now it's just saying up to equal what? Well, it's equal that expression that we're going to work. So we're looking at it being 68.6 plus list 2 times, in this case, it's supposed to be 2.9. So I'm seeing that same expression that I have right there for the general x values. So I got to do, when I enter it, I'm saying it wrong. Let me go back over here. This is around here. Oh, this too. A smart guy is supposed to do this one. There, this one. Oops. Therefore, there we go. So something I have over here for I need to clear it. So over here, I'm going to do the same thing. So 3, -2, -1, 0, 1, 2, and 3. So system merger is happening. They're all in there, going from left to over to the right through standard deviations. And once again, if I want to express this again, I gotta make sure this is highlighted, and I saw my expression. Well, it's supposed to be 68.6 plus shift second list, always this gives you the list, so always shift list gives you this. It's going to be list 1, that's where my z-scores are at, and we're setting my values. And we're going to put it times 2.9. And I'm in with the same values as over here. This list is a little bigger. And the zero standard deviation is going to be 68.6. Let's go and put these values in here so we can see what's happening. So looking at the first one over, it's going to be your 59.9, followed by your 62.8, and your 65.7. And this goes on the other side of the mean, on the positive side. So come over here, this is what we have. We have 71.5, 74, 71.5 right here. I'll make these points noticeable because they might be kind of hard to see. I do apologize for the earlier ones. But these are, when I say points, they're points. And over here it's going to be 74.4, followed by 77.3. So we got our parameters, and you know this is your list of values, x measures. So over here, what we're looking at here, we're looking at male height. So I'll put equivalent height, so height of male. Men. Okay. We know it's in inches. So these are our x measures. So it shouldn't be Z, it shouldn't be anything else. It's generally for men x measures. Okay. Anyways, so we got that out of the way. So now we can answer this question. It says right here, what percentage of adult men can fit through the doorway or through the door without bending? Well, if I'm not going to bend, that means that I have to be at less than the height of 59.2. I have to be less than this guy in order for me not to bend over. So I'm taller or the same size, I'm going to duck a little just to get through, or I'm going to crawl, depending on how tall I am. So what we're definitely seeing here is, wait, 59.2, well, over here for 3 standard deviation is 59.9. So 59.2 is a little further down here. It's a little further down here in this region. Or maybe a little further. But we definitely notice that it's definitely not within the middle 97% of your data. Because we know this is right here from 3 standard deviations over to 2 standard deviations, it's supposed to be approximately 99.7 of your data. So we're clearly seeing that it is smaller than, it's going to be some value that's smaller than 0.15. And we're going to see that when we actually do a calculator. So if it's outside of here, this range right here is pretty much looking at it being approximately 0.15 in that region, and same thing over here in this region. So we're definitely seeing a value that's going to be less than 0.15% away. Let's see what it really is. So let's actually put it into our calculator and see what is this supposed to be. So putting into our calculator, what we're looking for is normal distribution. So what we're going to be looking for is we have to get to our distribution, and we're going to be writing this value. So we're looking at the probability of our x measure is supposed to be less than, once again, 59.2 inches. So less than this. And we can find this using normal distribution. CDF. So why am I saying CDF? Because I'm looking at a range. This is a range, it's not exact. So it's exact with PDF, but this is a range. So CDF. And we're looking for our values to have an upper, lower, an upper, our mu, and our standard deviation. We need all that inside here. So what is a lower? Well, a lower is extending this way because it says less than. So it's going to negative infinity. And we should know negative infinity in a calculator. We could write it as negative 10 risen to the 99. The upper is going to be the maximum height for bending over, which is supposed to be a value that is less than, a little bit less than 59.2. So we put here 59.2, that's what we're looking at right here. The mu, well, we already know our mu is supposed to be 68.9. So I'll put over here 60, comma, not commas. Maybe we're in the right spot. A comma, 68.9. Well, let's put the 8.6. Where are you getting that from? Oh, I wrote 9 here. I keep writing 9. I don't know what's wrong with me with that, 6 and 9. But 68.9, 6 goes right here. So that's what's right. And over here is supposed to be your 2.9. Then again, because the standard deviation at 9 and then 6 is swapped on. But anyways, that's what we're going to be writing to our calculator, this expression. So come over here, first do it on the K4, because most people have this one. So come over here, well, distribution is right here where bars is at, and it's in blue. So that means I have to do second distribution. So second, then press bars to get your distribution, and there it is. And once again, I'm looking for CDF. I want the CDF one. So I can enter it, and I can ask what's my lower. Well, I already have here negative 10 to 99, but if you don't have that, I can just enter it in. Over here, I think I have the correct thing, which is supposed to be 59.2 for the upper. That should be correct. The next one down for the mu is supposed to be 68.6, that's good. And for standard it's supposed to be 2.9. So if you don't have this information in the calculator, please go ahead and put that in your calculator. So when you're done with all that, all you do is paste it by entering a paste. Oh, and I'm in the wrong location. Let me put this. And as you quickly thought about that, when you're doing this, don't be in list. Okay, don't be in your list. Don't be here. Because I already screwed it up right here. I gotta re-enter it. That was supposed to, I was not supposed to do it there. But let me just go ahead and take it real quick. So just quit it and make sure you're in the regular one and do it here. So distribution, normal CDF, and put the information outside. Don't put it inside in the list because it's going to flip the list and you might mess up in the rest of your calculations. So now, when I'm out here, it's going to be better because now it's going to enter it. It's going to say, is this what you want? And if it's matching what we have our expression on, then we're good. If it doesn't, then you got to fix it. So everything here is good. So now I'll enter it, and I'm in it with this. Okay. So that's interesting. So what is this saying? Well, it's saying that our probability happens to be 5.9482589888. This E means times 10. So it's actually times 10 risen to the negative 4. But this is not helpful because I want to know exactly what it really is. Because I'm talking about probability, I'm talking about what my mass is. Or in this case, density, aka area. I want to know what it is. So I want to know what the real probability is and how it's compared to this percentage. So what we're doing here is, well, our reminder that I have to do is get this, this here says move the decimal to the left 4 units. So I'm going to take this, so I'm going to do that. 1, 2, 3, 4. So I'm going to this equals over here now. So what we're seeing is 1, 2, 3 zeros before the 5. That's what we're really seeing. So if I were to round this to the nearest, to 3 significant digits, for the most part, what I'm seeing here is approximately 0.0001. 0.0595 if I round up to approximately 3 significant digits. But we definitely notice something here. This probability is, once again, one thing in the future, some technologies when you have might say less than 0.001, which is correct. This is a rare event. This will really happen. And or some other books or calculators might put, depending on where you're at, you might put 0 plus, which means that it's less than 0.001, but it's still greater than 0. Which means it's another way saying it's a very rare event. But we're not there at this time, but we do have a good idea of what the probability is. So now what I can do here, I can multiply this guy times 1%. Remember, I don't want probability, I want percentage. Keep that in mind. I don't want this probability. I want to run it as percentage. So what that means over here, I'm just going to multiply times 1%. But I'm moving the decimal over 2 to the left, or the calculator 2 to the right now, sorry, wrong direction. So we get a conclusion that we're seeing that approximately 0.05% of the adult men can fit through that door. That's what we're seeing, approximately. So, that's what this is getting to. So, once again, I did for one calculator, but what I'm going to do now is I'm going to do for all the calculators. And we should get the same answer, which is this guy right here, for this answer. But we have to answer this question. What is the percentage of adult men that can fit in the doorway without bending? Well, all we know is that it's approximately 0.05%. That's a very small percentage of men. It's one, that's for sure. And it's a half percent. So definitely, almost every man can fit through that door. Pretty interesting. But anyways, let's just go ahead and do this, get the same result using all the other calculators and get the same result for each one. So I just recently did it for the TA4s. So look at the conceal. Some of those guys are the conceals. Remember, right here, we could definitely make sure that this is showing, but this is not showing for the conceals. Make sure you do a second quit, okay? And it should be showing right here. And we see our distribution right here. So this distribution, well, we're looking at the normal. So normal is right here. And I want the CDF because, once again, it's a range of values. Make sure it's since we don't have a list, we have variables. We have information for the variables, so we're going to go with bars. So make sure bars is selected for data. And now put the differentiation here. Once again, lower is supposed to have been the negative 10 to the 99, so I'll put that in. So negative 10 risen to 99. So we got that enter. Next one, the upper is supposed to have been 59.2, so I'll put 59.2 right there. Into that. For standard deviation, we're supposed to be 2.9, so I'll put 2.9 for standard deviation, and the mean was supposed to be 68.6. So I got everything. You don't need to save anywhere. If you want to sort to the list, you can sort to a list, but you don't necessarily have to. And now I can just go ahead and enter, and we get the same answer. These guys are saying the same thing. And now I said E is supposed. Remember, I said E is 10 times 10. They're matching. So we have the same results. And let's look at this one here. It has a z-score, so we clearly know that this guy here is much further than 3 standard deviations away from me. And this is what I was showing, indicated right here. It's definitely more than 3 standard deviations away from the mean to the left. So it has to be about probably that's what was less than this guy. And we showed that it was much less than that. Okay, much less than that. But this guy's was actually further, it's 69, supposed to be 59.2. It's actually a little further down here. But anyways, that's what's happening there. So that's for the TI-84. Those are the inspires. similar thing happens, just make sure that you have your that you're in your calculate page. So if you need to go home, just make sure you do a new document or not. Just go to calculate, and you go to your calculate page if there's one not made for you yet. And now we're going to do the same thing. So one of yours is under menu. So first press menu. Then you can go to statistics because we're under stats. And now you're going to go to distribution, which is number 5. And then we have normal. So remember it's normal CDF because it's a range of values. And I can enter wrong one. Okay, when I do that, I always go one up when I try to click on it. That's why some people just go ahead and press the left and right, or just press enter, or the number. I always do it that way. So what negative infinity means the same thing. So you can put negative infinity here, or you could do 10 to negative 9. But anyway, the lower. So we get that one there. That one's good. Enter. Yes. Number bound was supposed to be your 59.2. So 59.2. Okay. That one's good. Okay. Come over here. We have the mean supposed to be 68.9 or 68.6, and your standard deviation is supposed to be 2.9. So we're picking the same thing. Everything is good. Golden is good. Remember negative infinity right here. You might not see, but it's negative infinity. But it's the same thing as saying pretty much, or it's probably the same thing as saying negative 10 to the 99. If you want to write negative 10 to 99, you can do that too. Okay. So do your choice. But anyways, all this looks good, and now I could pretty much okay it. So it gives me the same expression, and over here. It does, funny. Try to erase, but I couldn't. We're getting the same thing. Over here, they actually don't put it as active rotation, actually use the decimals, which is nice about this one. But is it this guy agreeing what we have over here? It definitely is. We have the same thing here. The exact same thing. We're getting the exact same result. And that is your probability. For those of you guys who don't have a calculator like this, you're going to have to actually write this expression here, which is not that bad. I'll show you that right now, so that got back by the calculator. But anyways, let's just say you have a distributed addition or a calculator that can write that in. Let me just first turn it on. We're doing the same thing. So it's under distribution again, because this is T84. So use the second distribution, and we're going for the normal CDF. And over here, we have to write in everything. So the lower limit was supposed to be negative 10 risen to the 99, comma. And then we have your 59.2, comma. Your mean was supposed to be 68.6, and our standard deviation is supposed to be 2.9. So all that's in there, and this once again is duplicating this. Make sure it duplicates what you have here. And we are golden. Oh, wait. Yeah, we're good. Commas in the right spots. So now I can enter it. And fun how this says 0. So let me just take my flow real quick. My mode. That, 99, 32, 39.2, okay. And this is where we definitely see when a calculator actually fails to give you what you need to get. So, like I told you guys before, some of your calculators might be saying 0, like I said over here. But just kind of stat for yours, you guys are trying, you're probably saying, it's 0%, which is not true. All we know is that it's a value that's 0.01. So when that happens for yours, the best thing for you to say is, because it's going to be the same thing in the book, you won't be able to figure out what it is. While we know in your book, what they will say is, when it comes up to this, we know is that our percentage, when we add this one, so we get our 0, our percentage will be less than 0.001 times 100%, which is going to be less than, in this case, 1, 2, it's going to be less than 1%, 0.1%. And that's all you would know. You won't be able to be as much precise as the other ones. But all we know is that it's a value that's less than 0.10%. That's all we know. So it's a good thing that I got back this calculator so you can know your restrictions in regards to it. But that's what we're seeing here. So hopefully the other ones don't do the same thing, but we're good with this one. Okay. So hopefully you guys caught on to that information, and over here, so that would be the answer for the other calculators, and the one we had before was approximately 0.05%. That was for all the other calculators. So knowing calculator, knowing limitation, I will be sending both answers since I'm expert technology, and I know the limitations for each of your calculators, so I'll be able to figure out your limitations. But let's move to the next example. Let's go ahead and clear this real quick. This is odd. I'm going to keep this here still. And I'm going to try to shade in the appropriate regions. This right here, we're going to erase and put back in where it is necessary. Limits. We got those out the way. So, everything else we're going to keep the same. Our doing is changing the question slightly. So, what we're saying here is, okay, fine. So, what if I want to adjust this doorway? Okay, what would the height be in order for us to fit 40% of the men? So, what is the question saying? It's saying what doorway height would allow for 40% of the men to fit under, to fit without bending over. So in order to fit without bending over, we have to make sure that obviously we're getting this guy. That's for sure. So what we're seeing here is we have no idea what this height is right here. We have no idea. But I want you to fit without bending over. But what I do know is that I know that 40% of this percent, but if we want to write it appropriately, this here has to be converted to proportions, so we can add the probability of it being 0.40 is what we're looking at here. So all we're seeing over here is this is your 0.404 as a proportion. So what we're seeing here is that we're going the other way. So if we wanted to get this graphically, what is it looking like? Let me erase what's here on top, where we got this guy out of the way. But what we're seeing here is, well, we know that the mean and the median is right here in the middle, which separates the bottom 50%. So we know this whole portion right here is the bottom 50. So we know our measurement is clearly going to be less than that. But keep in mind that this right here is taking up about 34%, depending on your class and your book, about 34%, or it might be 34.14, something like that. Can't really recall what this number is at this time, but it might be something like that. But all we know is that 40 is somewhere within here. That's all we know. 40%. So I'll estimate that my numbers right here. This is my X value I'm trying to find. That's going to help it be the bottom 40. So here's the bottom 40%, which I'll refer to as 0.40 in terms of probability and area. And so we get up to see that what's complement of it, your top 60. Also referred to as being as probability or area, 0.60. So once again, there's actually two ways to answer this question. If I go to right, to right, there's no left, you have to do that. This could be another situation that can happen. But anyways, this is the idea what's happening. We have to understand what's really happening, where it's located. I don't know exactly where it is, but once I find it, I'll put it where it belongs exactly. But it's just written here based off my assumption of what this middle portion is right here. But let's actually do this. So once again, if I was going to find probability knowing the x values, it was normal distribution. But now I'm going the other way. I have area. I know the area, I know the probability. So if I'm going this way, I must do inverse. So what we're looking at here is actually, if we want to find out what this x value goes inside here, wherever this x measurement is, we know it's going to pretty much equal this x measure that we're looking for is going to be the inverse norm. And I think you put NB, I and B, inverse norm from CDF. Remember, they got a range. And we do the same thing. You have here lower, which goes below. No, actually, it's supposed to be area, which is probability, and we get our mu and our standard deviation. This is what some calculators have. Other calculators have an option right here to put either left, I'll put this with a different color, but most calculators are stopped here. Well, I know Inspire and the Silver Dish is stopped there, but if you have the option to put left, right, center, you can do left, right, center. Comes down to your choice, what you want to do. Anyways, some have this, some don't. So know your limitation in your calculator, but note that if it doesn't have this choice, all you're stuck with is this. If you don't have this choice, you're stuck with just left. And then that's your calculator is always going to do. It's always going to do a left if you don't have that choice. Anyways, let's go ahead and get this one done. So what we definitely know here is we know our areas, we know our information. We know that inside here, we know that we come up, we want to fit, so we know that has to be the bottom 40% to fit. So we're looking at it being pretty much, and this error is going to be 0.40, which goes here. The mean is going to be the same thing, which is our 68.6, and our standard deviation is going to be 2.9. That's what we're seeing. And if we have an option, since we're looking at a left tail function now happening here, we're looking at the left area, you'll be choosing left. Okay, to go there. But if you don't have the option, you're kind of lucky, it's already left, lucky us. But with that for the top 60, to actually not feel bending, then it will be the opposite. You have to put something different right here. But we'll see that in the future, but it's left. So all calculators will do the same thing. So I'm not going to do it for one calculator because obviously it's the same thing, just that instead of doing one, you're doing the inverse. So I'll do it for the Casio, or I'll do it for the two that's which off to the side. Actually, I'll put this one here because that's the one that's going to deal with it. But screw it, I'll do it for all of them, or most of them. Anyways, once again, I exit the Casio, exit, and I can do distribution again. Remember, it's normal, but once again, it's inverse norm. So IB norm. And now I'm going to, once again, over here we have an option. Measures and variable, because you have variable information. Central, not central, I want it to be left. So left, right, center option. So I'm going to do left. For area, it's supposed to be 0.40. So it's wrong. 0.40 to go there. My standard deviation looks right, 2.9, and my mean is supposed to be 68.6, so we're good there. So everything else is good. So I can enter it, and it says that, we're saying that if we want to fit at least 40% of the people, or 40% of the people, the height would have to be 67 point, in this case, 9. Because once again, if you look at our data, we do have rendezvous. Rendezvous says that the measure for the standard deviation of mean is supposed to be 0.9, and look at our 0.2 inches, it's supposed to be 0.2. So since we're trying to keep consistent to what the measurement is, but usually what's supposed to be the case is supposed to be 1 decimal beyond, but what we're definitely seeing here is this one has 0.2, So we're gonna go with what's here, but what's supposed to be happening is the root that's over here. So the root says that I must go 1 decimal beyond. So all these heights here for min, where it's actually supposed to be solid whole percents. But anyways, to put it here, so if you want to follow the proper rule, we're saying over here is going to be 68 in terms of the round 1 decimal beyond. But because our information actually has a decimal in here, so it wasn't following the rules it's supposed to be doing for our book or for information, we're going to go over here and put the 68.9 since we have decimals here. Then over here we have decimals, we'll go over here. But if we didn't have this information and this was gone, this was not here, we had no idea what this expression was, we had to go based off this guy, which says that we go 1 decimal beyond the given data. So the data should have been whole number. It should have been. This would be the true correct one. Okay? This one here is somewhat. It's not really correct. So let's watch out for those things. It can happen. So all we know is over here, we should be putting the 50, 68, 69 here. And over here, we know what kind of answer it is. 69 inches. Once again, all we're saying here is we should be following the rule of the mean and standard deviation, because it's told this we're supposed to round 1 decimal beyond. The answer should have been whole number. It should have been decimals in terms of extra values. Anyways, that's what's happening here. So let's see how it's working for all the other calculators. So this one's here right now, so I'll do for this guy. So once again, this one here should give me already a left. So I'm going to do second distribution, inverse norm. And now I'm going to put in information again. It's supposed to be error 0.40, comma, supposed to be the mean, which is supposed to be 68.8 or 6. Keep messing with that one. 6 right here, comma, 2.9. So now when I enter it, I should get the same result. Enter this back in. And notice how we're getting the same result. Okay? So we're getting the same thing that happens over here. So if you got to write it in, write it in. If you don't, then you're okay. We're just in the same format as all the other calculators. So let me just quickly show the other ones as well, get the same answers. So I'll go with the color, since it's the one that's the upgrade of TI-84 silver. So once again, same thing is occurring. Second distribution, inverse norm. And over here we have left, right, center option. So remember we're doing left. But the error is supposed to be 0.4. So I got that in there. Standard deviation is supposed to be 68.6. And standard deviation is supposed to be 2.9. All that's looking good. Left area. And when I paste it, it looks just like the one before, just that we have the left option, like I said. It's supposed to be saying left. Okay? So, all we gotta do is press enter, and we get the exact same answer. Over here goes a little further, that goes further out, but we're coming to the same approximate answer. And same thing for the inspire. I'm gonna get the inspire now. So under Inspire, we do the same thing. Some people type it in, which is cool. Like, I'm not good with quick typing, so I haven't practiced it too well. But I always go menu. I go down to stats. I go down to distribution. And now I'm going to choose inverse normal. Okay. So notice how I don't have left, right, center options. So I know this is left area. So once again, I'll put 0.40 in there. Mu, once again, is supposed to be 86 points. That's total opposite what it's supposed to be. 68.6 and 2.9. So everything that's good, and now when I enter it, it's supposed to read the same thing as right here, and we have the same result. Right here we have less decimals, but we still see the same rounded information. They're agreeing. Some people actually write this in, which is pretty cool. You write it in, if you're quick at it, go ahead. I'm not saying no. Go ahead and do so. It's faster for you. But anyways, we're all getting the same answer. So what's the answer? Well, the correct answer is supposed to be pretty much 6 to 9 inches. If we don't have this information with the luxury planes. But if it's provided for us, well, we can go with it because it's in here. But the correct answer is supposed to be that's 1 decimal less than the given standard deviation mean. Because the rule of standard deviation mean is supposed to be going beyond, based off our book. Okay? Based off the book we're using. So there's no new book, no restrictions. Because the books will change. But anyways, that's it for this set of problems. Hopefully everything was good. And I'll be making different set of problems that deals with the in-between situations and the areas that are different. But this is for that one, and just open up the next set of videos. Okay? Thank you.